Welcome to Quiz Zero. On Quiz Zero, we are going to solve a few basic questions. The first question is make the subtraction of two fractions. You have the fraction 320, and you need to subtract to the fraction 4 divided by 15. And to make a subtraction, you need to have the same common denominator. In this case, you don't have the common denominator. So how you do the subtraction of two fractions? Well, the first things that you may apply this equation that the sum of two fractions is a multiplied by d. You see a multiplied by d plus c multiplied by v divided by b multiplied by d. This is the sum of two fractions. So we may apply this equation to the sum of two fractions. And now the sum will be, we apply with this minus sign. So it will be 320 plus 3 divided by 20 plus minus 4 divided by 50. So it's this by this minus this by this minus because of this minus sign. A by D plus C by B divided by B multiplied by D. So if we make the sum, this is just algebra operation, you can find the correct answer, and the correct answer will be minus 35 divided by 300. That probably you can reduce this, oh yes, is reduced here to minus 7 divided by 60. So minus 35 divided by 300 is the same that minus 7 divided by 60. So if you divide 300 between 60 is 5 times. 5 times you divide 35 by 5, you obtain 7. If you divide 300 divided by 5, you obtain 60. So this is one way, and the other way is to look for the common denominator. I think that you know how to look for the common denominator to write the expression in another way, and you can do it. Let's go to the next question. The next question is say to compute the square root of two numbers square. So this remind you to the Pythagoras theorem. So if you have 5 on one side and 12 in the other side, the hypotenuse will be 5 squared plus 12 square root. So we need to find to compute this sum. 5 squared is 25, 12 squared is 144. The sum is 169. And the square root of 169 is 13. So you have a triangle that is 5, 12, 13 is a triangle that with a 90-degree here, and Pythagoras theorem is applied, and this is the calculation, is 13. Okay, let's go to find the derivative, the slope of a function. So we have the function x squared cosine of x is a good function, is the product of x squared multiplied by cosine of x, and we need to find the derivative of the function. How you make the derivative? You use rules for the product of two functions. So you have two functions here. One function is the x squared, the other function is cosine of x, and you have the product of two functions. And when you have the product of two functions, the derivative of the product of two functions is the derivative of the first multiplied by the derivative of the second, multiplied by the second without the derivative, plus the first multiplied by the derivative of the second. So if you have the function f of x, g of x by h of x, the derivative of this function, the derivative prime of x, so the derivative of x respect to x is the derivative of the first multiplied by the second plus the second multiplied by the derivative plus the first multiplied by the derivative of the second. So this is the derivative of a product of two functions. So we apply this equation to find the derivative of the product of two functions. So let's go to do it. So in this case, g of x is x squared, and g prime of x is 2x. In this case, h of x is cosine of x, and h prime of x is the derivative of cosine of x, which is minus sine of x. The minus sign here is the correct sign for the derivative of cosine of x. So the derivative of the product of the two functions, the derivative respect to x of the product x squared cosine of x is the derivative of the first 2x by the second cosine of x plus the first x squared plus multiplied by the derivative of the second minus sine of x. So 2x plus x squared, there is a common factor on x that I can work. It will be x that multiply 2 cosine of x plus minus x minus x sine of x. So this is the final result. 2x multiply is correct. So this is the final result. Let's go to the next question. The next question is compute again another derivative. When you have a derivative that is e to the x is a nice function. E to the x, when f of x is e to the x, the derivative of f of x is e to the x, is the only function that the function and the derivative are equal. So what happens if f of x now is not e to the x, is e to the power of f of x, like this one. Now the derivative f prime of x is e to the power f of x multiplied by f prime of x. So let's go to apply this rule to find the derivative of this function. So in this case, f of x is I made a mistake. I make a big mistake. I should put here e to the g of x. Sorry. So the derivative f prime of x is let me erase here, is e, let me erase here, sorry. I'm sorry. F prime, well, it's written here, is e raised to the power g of x by g prime of x. This is the derivative. So in this case, g of x is minus 5 of x, 5 multiplied by x. And g prime of x is minus 5. So the derivative, f of x, is e raised to the power minus 5 of x, and f prime of x is e to the power minus 5x multiplied by the derivative of minus 5x, which is minus 5. So the final result is minus 5 times e to the minus 5x. Let's go to the next question. So what we have learned in this question, that when you do the composition of two functions, you are applying the chain rule for this composition, and it will say that the derivative of, if f of x is e raised to the power g of x, the derivative e to the power g of x multiplied by g prime of x. In other words, the derivative of x respect to dx is the derivative of f respect to g multiplied by the derivative of g respect to x. And this is what we have applied. Okay, let's go to the next question. Now, the next question is just a practice from integral. It says, what is the integral of secant x tan x? Secant x is the reciprocal of cosine of x. So let's go to right, secant x. Let me see if I wrote it here. Let me see, secant x. So to do this kind of integral, we need to pay attention to the derivative of secant x. The derivative of secant x respect to x is the derivative respect to x of 1 divided by cosine of x, the reciprocal of cosine of x. And if you remember, the derivative of a quotient of two functions is the derivative, this is the rule, the derivative of the first multiplied by the second minus the first function, the numerator, by the derivative of the denominator divided by the denominator square. So I repeat again, the derivative of the quotient of two functions is the derivative of the numerator by the denominator minus the derivative of the denominator by the numerator divided by the denominator square. So if we want to find the derivative of secant x, or the derivative of 1 divided by cosine of x, we need to apply this equation. So let's go to find the derivative of secant x to realize why it's important to have this derivative. So the derivative of sine of x is the derivative of the first, the derivative of 1, the derivative of the numerator, which is 1, the derivative is 0, by the denominator, cosine of x, minus the function, the numerator 1, multiplied by the derivative of the denominator, but the derivative of cosine of x is minus sine of x. So in the numerator will appear 0, minus is plus, it will appear as sine of x, this here, divided by cosine square of x, the denominator square. The denominator square is cosine square of x. So this can be written like sine divided by cosine is tangent of x. So it's tangent of x multiplied by 1 divided by cosine of x, or in other words, tangent by secant. The derivative of secant x is tangent of x by secant of x. Why this is important? Well, because you know tangent of x, secant x, it appears here, tangent x, secant x. So if the derivative of secant x is tangent x, secant x, it means that the antiderivative of tangent x by secant x is secant x. So the problem is already solved. The antiderivative, you see you can read this like this. What is the antiderivative what is the antiderivative of secant x multiplied by tangent x? Or in other words, what is the function whose derivative is secant x tangent x? And I found the function whose derivative is tangent x secant x is secant x. So the problem is solved, and the solution here is secant x plus c. So let's go downwards to see. While I did the integral, is the same. I did the integral in both sides. So this integral is an inverse operation to this derivative. So it will be secant x equal the integral of tangent x by secant x ddx. So the integral of this, the antiderivative of this, is secant x. Let me see what is here. So secant x is the integral, and the problem is solved. Let's go to the next one. So the next one, it says compute the following integral. It's a basic integral. It's the integral of the product of two functions, x 1/2 multiplied by x plus 1. So I will apply the power rule that says that the integral of x raised to the power n ddx, this integral is x to the power n plus 1 divided by n plus 1 when n is different than minus 1. This is the, when n is equal minus 1 is another integral, but the power rule say that the integral of x to the 3/2, for example, x to the 3/2 ddx is x to the 3/2 plus 1 divided by 3/2 plus 1. Or in other words, x to the 3/2 plus 2/2 is 5/2. 5/2 divided by 5/2. Or in other words, 2/5 x to the 5 divided by 2. X raised to the power 5 divided by 2. So this is the power rule to remember. So we go and we do the integral now using this basics fact that is the power rule. So first we multiply this by this. We use distributive property. This by this is x raised to the power 1/2 multiplied by x raised to the power 1. We multiply x to the power 1/2 by 1 with this x to the power 1/2. And you remember from elementary algebra that x to the n multiplied by x to the m is x to the n plus m. So this one will be reduced to x to the raised to the power 1/2 plus 1, which is 3/2. So it will be arrived x to the 3/2 by ddx plus x raised to the power 1/2. Now I can use the power rule. X to the power 3/2, I already did, is x to the power 5/2 divided by 5/2, and x to the power 1/2 is x to the power 1/2 plus 1. I will write the 1 like 2 divided by 2, so I can sum, and it will be 3 divided by 2. So 1/2 plus 1 is the same that 1/2 plus 2 divided by 2, which is 1. And now I can sum, is 3 divided by 2. I sum the two fractions. So the final result will be equal 2/5 x raised to the power 5/2 plus 2/3 x to the power 3/2 plus c, plus a constant. Because any function, any c constant, any constant that I put in that I will add to this function, the derivative because the derivative of c will be 0. The derivative of this will be this. This is what I found. If you don't believe me, you make the derivative. Let's go to do the derivative to check if I did it correct. The derivative of this function will be 5 half multiplied by 2/5 will be 1 raised to the power x to the derivative. I'm just checking now if I did it right. How I will check it. I will make the derivative of 2/5 x to the power 5 divided by 2 plus 2/3 x to the power 3/2 plus c. And I want to prove that this derivative should be this function, this one, should be this x raised to the power 3/2 plus x raised to the power 1/2. Let's go to see if it's true. It will be true. Well, we go and we make the derivative. To make the derivative here, it will be 5 divided by 2 plus 2/5 x to the power 5 divided by 2 minus 1, which is 3 divided by 2, plus 2/3 multiplied by 3 divided by 2 x to the power, I'm making the derivative of x raised to the power 3/2 is 3/2 by x raised to the power 3/2 minus 1, which is 1/2, plus the derivative of c, which is 0. So it will be equal, this will This rectilinear line is this line that have a slope 4. What is the equation of this line? The equation of this line is y equal y1, 4, plus the slope 4 multiplied by x minus 2. Or in other words, y equal 4 plus 4x minus 8. Or in other words, y equal 4x minus 4. Or in other words, 4 multiplied by x minus 1. Okay, with this we have solved question 5, question part 5. Let's say find the rectilinear line at the point x equal 2. Can you do the tangent line to the point x equal 3? This line. Can you find this line and do the same? This tangent line. So, can you find this tangent line? For sure, do the same thing and find its tangent line. You do not need to do the limit because we know how to find the slope. The slope is making the derivative at the point. The slope here, the slope at x equal 3, if y equal x squared, the slope, the derivative of y respect to the x is 2x, and if you evaluate at x equal 3, the slope is 6. So the slope is growing up. At x equal 2, the slope was 4. Now at x equal 3, the slope is 6. The slope is growing up. So the other question that says, considering the function x plus 2, the part B, let me erase here. Well, part B say if you consider the following function, this one that is the one that is the same that x squared but is higher 2 units. So if you consider, the function that is higher 2 units has exactly like x equal to the same slope. If you go to x equal 2, the function will have exactly the same slope that this function. Let's go to do it in green. This slope will be parallel, will be the same slope at x equal to, so x squared plus 2 have the same derivative, 2x. So if you make the derivative of x squared plus 2, it will be 2x. And at the point x equal 3 will be 6, and at the point x equal 2 will be 4, 2 by 2. So I wish you have enjoyed this course. I will support you doing this kind of video to try to help you and to support you as much as I can. Good luck in this course and welcome to the course.